Myself, Dr. S. Priyadarshini, heading Department of Mathematics at JJ College of Arts and Science at NMS. So today this video is about fuzzy mathematics for 3rd BSc Mathematics students under discipline specific elective. We're going to see about in Unit 1 operations on fuzzy sets, and also before entering into the concept I'm going to explain how fuzzy arises and what does it mean. So in this video we are going to discuss about classical set, fuzzy logic, and finally operations on fuzzy sets. So first, classical set. So classical set is nothing but crisp set. Normal set we are defining, right? So set of all fruits, the first example. Before entering into the definition, my style is giving the example. So set of all fruits as an example, and set of all elements in the format of a1, a2, a3, and set of all even numbers 2, 4, 6, 8, etc. So this is the general example by statement. Okay, we can say that is the set of all fruits, set of all elements, or set of all even numbers, right? So in mathematically, how we can express this set is a equal to x such that x is a set of all even number, and a equal to x such that x equal to 2n, where n is a set of all natural numbers, right? Likewise we can define in mathematical. And next we going to discuss about the characteristic function or membership function. So membership function or characteristic function is nothing but whenever we have to define a set and also an element. If an element belong to the particular set, we give the value 1. Otherwise, if does not belong, the value will be 0. That is called as a characteristic function or a membership function. Okay, we have to give the result 1 if the particular element, that is particular element, is generally represented as x. If x belongs to a, the resultant will be 1. If x does not belongs to a, then the resultant will be 0. So this is the characteristic function, also called as membership function. Okay, now we're going to enter the fuzzy, very interesting topic and my lovable one. Okay, now enter into this topic. I have displayed some pictures here. Okay, so the question is roses red? Next, is roses not red? Is roses not red, right? So this is or whenever the fuzzy arises, there will be 3 reasons. After seeing this video, you can comment what is the 3 reasons. Okay, next. So okay, what color is this leopard? So when we watch this leopard, you can able to see number of dark spots and yellowish brown color, and there's some more white color also rises. So this is unpredictable, right? Okay, next question. So you can watch this. We can able to see a glass which contains some water. Now we have to answer the question. What is the question? Is this glass is full or empty? We cannot give the accurate answer. That is fuzzy. We cannot give the accurate. Can you answer this is full or empty? Yes, this glass contains full of water, or this glass is empty with water. No, unpredictable. Okay, next. This is a bowl of orange? It's okay. The same. Crisp is yes or no. So fuzzy can be imprecise or not clear, not cut and clear. Okay. For example, I can able to always explain for my students. Okay, a driver is driving car, right? So he is driving in the front seat, and the man who guide the driver is asking take right. Okay, he can take right, so no problem. If this man asks him to take left, if the driver answer right, what does it mean? Whether he going to take left or he going to take right. This is the imprecise condition. So vagueness, imprecise, and unpredictable leads to the fuzzy. So fuzzy logic is a superset of conventional logic that has been extended to handle the concept of partial truth values between completely truth and completely false. Yeah. So we know that classical set is always accurate, accurate, perfectly accurate. So for example, we can see this example: contain object that satisfy precise property of membership. That is perfectly. If you want to make a mapping with 4, you have to make a mapping with perfectly on 4. But in fuzzy, you can make the mapping absolutely 4. Okay, mapping start with 0 and move on to 4 and end with 8. That is fuzzy. You can start with 0, your highness go to, that is highest mapping, go to 4, and the edge again move to 8. That is fuzziness. So here you can see this as a characteristic function. I already stated this, whether that elements belongs to that particular set, then you can able to take the value 1, otherwise it will be 0. So here define set of all heights from 5 to 7. So the mapping from 5 to 7 have the value 1, and mapping with the elements other than 5 to 7 take the value 0. So you can get this particular box in the mapping. Whether if you take this mapping in fuzzy, it will be a bell shape. Yeah. Now you can able to see the fuzzy set. Contains object that satisfies the imprecise property of membership. That is the set of heights in the region around 6 feet. Okay. So the 6 feet is the maximum limit, but you can also able to choose 5 and 6. That is fuzzy. The mapping start from 5 and end with 6. But the highest mapping is at the 6. Again, you can able to follow this, already I stated it. Even maximum it will be bell shaped. There is various shapes in fuzzy: triangular, trapezoidal, bell shape. And that is, we can discuss a separate video about that shapes on fuzzy. Okay, so now we are in the basic concept, so I am giving some very little tips about the fuzzy. So now you can able to see this, the fuzzy concept: number close to 4, number closest to 4. That's all. So number closest to 4, you can start from 0 and end with 8. I have already explained, So that's such kind of mapping you can able to see here. Because fuzzy always be defined the error between the mapping 0 to 1, closed interval 0 to 1. We can able to move this error. It's okay. While entering this topic, fuzzy logic, it is very widely extended application in any area. We cannot able to think about it, such a wide range of application it consisting. Because whenever we think about mathematics is applied only in the field of engineering or physics or chemistry. No, fuzzy is also applied in environmental science. It is we have to unbelieve, but it is a true. Before 10 years they have applied fuzzy into environmental science, and they have got very better results. So fuzzy, it can be applied in any area. The main thing is we can able to minimize the error in between the closed interval 0,1, that is 0 to 1. So the error in the gap between 0.1, 0.2 to 0.9 likewise. So we can minimize the error and we can get the better result by this fuzzy. And also it can be widely used in the area of automation. The best application is automation. And whenever we are thinking about this washing machine, right, this fuzzy have been applied there. Okay, here I have explained only one application, fuzzy logic. In the image stabilization, you can able to see here, if all the motion vectors are almost parallel and the time differentiable is small, then the hand jittering is detected and the direction of the hand movement is in the direction of the moving vectors. Image processing, data analyzing, artificial intelligence, neural networks are all the application of fuzzy. You have to go inner depth to understand it. First of all, you have to understand the basic concepts. Okay. So we are going to the fuzzy set. So a characteristic function, the value assigned to the elements of the universal set fall within a specific range and indicate the membership grade of this element in the set. And I have already stated that the fuzzy set range in the value of membership function in the unit interval 0, 1. Simply it is a mapping from an universal set to closed interval 0, 1. So now we are entering into the basic operations, that is complement, union, intersection. These are the basic operations on a fuzzy set: complement, union and intersection. Okay, generally we are clear about the complement. Okay, but here the complement is 1 minus the fuzzy set. The general complement is universal set minus the particular set, but here 1 minus the particular set. The standard complement of a fuzzy set A with respect to the universal set A, X is defined for all X belongs to X by the equation A complement of X equal to 1 minus A of X. Okay, you can able to see clearly in this picture the complement, right? Next, that is I have stated the standard intersection and union. So intersection, you have to keep in mind, intersection always be a small set. So intersection must be minimum. Union is merging two sets, so it must be maximum. This is a shortcut to understand this. So A union B of X is minimum of A of X and B of X, and A intersection B of X is equal to minimum of A of X and B of X, and A union B of X is equal to maximum of A of X and B of X. You can say, you can able to watch that intersection region, that is minimum, that covers both region of the A and B, and union is you should cover the both. Okay, so this slide shows some basic concepts: normal, subnormal and convex, which is also some properties of the fuzzy sets. And also you can say you can able to visible that intersection parts of this in this figure. Keep on watching. So basic property is complement, union and intersection. Complement is 1 minus the set, and union is maximum and intersection is minimum. So these are the fundamental properties of set operation, crisp set operation. We can compare with the fuzzy set, but the main concept that should not satisfy the fuzzy and the crisp is very most important thing you have to keep it in your mind is law of contradiction and law of excluded middle, which should not be satisfied, which is entirely contrary from crisp set. That is, law of contradiction is whenever A intersection A complement in normal set which is empty, but in fuzzy A intersection A complement must not be an empty set. And also law of excluded middle, whenever you make an operation A union A complement, you will get the universal set in normal crisp set, but in fuzzy set you should not get the universal set. Okay, so what is the contradiction of this two set means you have to be able to understand that two rules which should not satisfy the condition of the normal crisp set with fuzzy is entirely different, entirely contradicts only two conditions: law of contradiction and law of excluded middle. That is A intersection A complement and A union A complement. Keep it in your mind. Thank you.